Welcome to Miss Smith's Math Tutorials. I'm Miss Smith. In this video, we're going to be talking about parallel lines and angle relationships. A couple things we want to establish is that A and B have to be parallel lines in order for these to work. So this is operating under the assumption that A and B are parallel. This cut through line is called a transversal, this C line. He is cutting through two or more parallel lines, and it creates these angle relationships, and we're going to talk about those. One thing that we do need to establish is this symbol. This means congruent, and it's essentially an equal sign, but we use it specifically when we're talking about shapes or angles or triangles and all that stuff. So this means congruent. It means the same or identical or equal. The first type of angles that we're going to talk about are corresponding angles. The easiest way I can sum it up is like you pick an angle and then you skip one and you go to the next angle. And let me show you what I mean. Like pick number 1, skip number 3, go to number 5. Okay, so 1 and 5 are corresponding angles. And I could do the same thing with 7. I could say, all right, I pick 7, skip 5, go to 3. 7 and 3 are corresponding angles. So we just laid out 2 of them, so let's write those. We've got angle 1 and angle 5. And then we said angle 3 and angle 7. What else could we get? We could do angle 2, skip 4, go to 6. So angle 2 and 6. Then we could do 8, skip 6, go to 4. So 8 and 4 are corresponding angles. Angle 8. Our next type of angle that we're going to talk about is alternate exterior angles. And I should know, I don't know if I mentioned this when I was up here, but corresponding angles are congruent. So that means that angle 1, whatever the value is for angle 1, whatever the measurement is, angle 5 will be equal to that because they are corresponding angles. So I want to make sure I make that very clear. For alternate exterior angles, these angles are also congruent to each other. They are equal to each other. And the easiest way to sum it up is they are outside of the parallel lines. So let's think about it. If our parallel lines are here and here, the outsides would be 7 and 8 and 1 and 2. These 4 right here, they would be inside the parallel lines. These are outside. So alternate means switching sides, if you will. So 1 would be an alternate exterior angle with 8. They're on opposite sides of the transversal. We've got 1, angle 1, and angle 8. And then we also could say angle 2 and angle 7. Those are also alternate exterior angles. Angle 2 and angle 7. All right, next we have alternate interior angles. These angles are also congruent with each other. They are the same measurement, the same number of degrees. So these are inside, like interior means inside of parallel lines. So if our parallel lines are A and B, our inside angles are going to be the 3 and the 4 and the 5 and the 6. And again, alternate means we're switching sides. We're going the other side. So we could start with 3 and go the alternate side down here in 6. So 3 and 6 would be alternate interior angles. So angle 3 and angle 6. And then our other alternate interior would be angle 4 and angle 5. All right, our next type of angle is consecutive interior angles. Okay, so these are inside of the parallel lines, similar to the alternate interior angles. They are also inside, but these are next to each other. So meaning 3 and 5 would be consecutive interior angles. We're not going alternate. We're not switching to the other side. We're going consecutive, straight down. So 3 and 5 would be 1, angle 3, and angle 5. And then the other consecutive interior would be angle 4 and angle 6, so right beside each other. And an important thing to note about consecutive interior angles is that they're not congruent with each other, okay? And I can even look at 3. I see this is clearly an obtuse angle. It's larger than 90 degrees. And this 5, it's clearly an acute angle. It's less than 90 degrees. So I can just look at those and tell those are absolutely not congruent. But what do I know about them? They add to 180 degrees. Okay, so 180 degrees, that's going to be a big number that we work with a lot as we go through our angles and triangle units. So you want to get used to that number. But consecutive interior angles add to 180 degrees. Our next angle is vertical angles. So these are angles opposite each other. So I kind of think of them as like the X angles. Okay, so for example, 1 is opposite with 4, right? Angle 1 and angle 4. And you see how it creates like an X shape? So on one side of the X is 1 and on the other side is 4. Those two angles are congruent with each other. So we've got angle 1 and angle 4. Okay, let's see what else in that same X, right, that we've created. I could see angle 2 and angle 3 are directly opposite each other. So those are also vertical angles. Angle 2 and angle 3. Looking down here, we could go with 5 and 8. Those are vertical angles. Angle 5 and angle 8. And then our last one would be angle 6 and angle 7. Those are also straight across from each other and they are congruent. Angle 6 and angle 7. Okay, two other terms that you're going to hear. So I just want to lay out right at the beginning what these terms mean. The first one you're going to hear a lot in both of these forms. Supplementary angles, linear pairs. Those are angles that add up to 180 degrees. An example here that I've drawn, just a rough sketch of a linear pair. Notice that 1 and 2 are on one side of a straight line, and we are assuming that that is a perfectly 180 degree straight line, okay? And even though it's cut into two angles, right, 1 and 2, if I can draw like a little rainbow half circle like that, then that means this is a linear pair. They're supplementary angles, and they add up to 180 degrees. So that's something that's really going to come in handy when we start doing more stuff with triangles and different, almost puzzles, trying to figure out what angles are what values. This is going to be a really helpful tool. If you can identify those straight lines and the linear pairs, that can help you determine what those angles are. So the other term I want to talk about briefly is complementary angles. So this we won't see as much in our units, but it will pop up every now and again. So if two angles or two or more are complementary, that means they add up to 90 degrees. So an example here, you can see this is a 90 degree angle, and it's marked with that little box, which means that's math language for it, that is a 90 degree angle. Okay, so even though it's cut in two, I know that 1 and 2, if they are complementary, they will add up to 90 degrees. Let's look at some examples of different angles and identifying them. So here's the first one. If the measure of angle 1, okay, angle 1 right there, is 140 degrees, find all other angles. Now that may seem like a daunting task. You may think, I don't have enough information to do that. But if we just follow those rules that we went through on the first page, we can actually identify every single one of these angles just by knowing one of them. Again, we are operating under the assumption, and the assumption is I'm telling you that A and B are parallel to each other, and C is a transversal that cuts between them. We are operating under that assumption. Let's go ahead and measure what angle 1 is. So it told us 1 is 140 degrees. So I could go a number of different ways from here based on those rules, but the first one that sticks out to me is if 1 is 140 degrees, then so is 4, because those are vertical angles. They're directly across from each other, and I know vertical angles are congruent. So I know 4 is also 140 degrees. All right, now from here, I could say, well, 4 is an alternate interior with 5, right? They're on opposite sides of the transversal. They're both on the interior of the parallel line. So I can say 5 is also 140. And then from 5, I could say, well, 5 is a vertical angle with 8. So vertical angles are congruent, just like we did 1 and 4. So I can say 8 is also 140 degrees. Okay, so I filled in all my 140 degrees, but what about 2, 3, 6, and 7? Well, there's lots of different ways I could approach this, but I'm going to go with, I see right here, I've got this nice straight line, right? So that tells me when I have a straight line and then some angles split between it, I know that those angles have to add up to 180 degrees. They are supplementary. They are linear pairs. 5 and 6 are currently linear pairs. So if I know that this line has to add up to 180 and angle 5 is 140, well, let me get out my calculator. 180 minus 140. Well, that gives me 40 left over. So that tells me that 6 has to be 40 degrees. And now if 6 is 40 degrees, 6 is vertical angle with 7. So 7 has to be 40 degrees. And I could say that angle 7 and angle 3, remember our pick one, skip one, go to the next one, are corresponding angles that are congruent. So if 7 is 40 degrees, so is 3. And then 3 is vertical angles with 2, which means 2 has to be 40 degrees as well. Okay, so you see, if we just know 1 in a situation like this, we can pull out every single measurement of each angle. Let's look at this one. So it's given me a picture, and then it says find x for each of these questions. Now I should note that these questions are all independent of each other, meaning, you know, if it tells me measure of angle 2 is 165 degrees, that's just for that one problem. Okay, I don't take that and then build on it. It's just for this problem, imagine that was true. Okay, for this problem we'll have a different number that we're working with. Okay, so let's see. So I see that I've got A and B here, okay, and we are operating under the assumption that these are parallel lines, and I see C is a transversal that cuts through them, and that creates all kinds of angle relationships that I can build on. So for this first one, it says if the measure of angle 2 is 165 degrees, and it says the measure of angle 7 is 5 times x plus 10. Okay, so what I need to recognize is what is the relationship between 2 and 7? Well, they're on the interior side of these parallel lines. They're on the inside, okay? And they're on opposite sides of that transversal. So that tells me these are alternate interior angles. And what do I know about alternate interior angles? Well, they're congruent. They're equal to each other. So what I can actually do is take this measure of angle 2, 165, and I could set it equal to 5x plus 10. Now at this point, this is just a basic algebra problem that I need to solve for x, because that's what it wants to know, find x. So in this case, I would subtract 10. I'd get 155 equals 5x. Of course, I want to divide both sides by 5. So I know x equals 31. 1. All right, now let's look at the next one. Okay, so again, this is a totally different, we're getting rid of that 165, moving on to a different problem. Okay, for this one, it says the measure of angle 1 is 6x plus 5. So we're right here at angle 1. The measure of angle 8 down here is 35 degrees. So let me see, what is the relationship between 1 and 8? Well, I see they are on the outsides, right, of the parallel lines, and they are on opposite sides of the transversal. So that tells me these have to be alternate exterior angles. They're on the exterior, the outside. So to solve this, I know that alternate exterior angles are congruent to each other. They're equal. So I can set 6x plus 5 equal to 35. And let's solve for x. So I'd want to subtract 5 from both sides, and I would get 6x equals 30, right? We'll divide by 6, running out of space, and we get x equals 5. Let's try this last one. If the measure of angle 2, so we're right here at angle 2, measure of angle 2 is 5x minus 10, and the measure of angle 5 is 75. Okay, so what's the relationship between angle 2 and angle 5? Well, I see they're both on the inside of the parallel lines, and they're on the same side of the transversal. So I've got to think back. Those are consecutive interior angles. They're consecutive, they're right beside each other, and they're both on the inside, right? And I got to remember, what's the relationship between consecutive interior angles? And they add up to 180 degrees. So this time, I'm not going to set them equal to each other like I did the other ones. They're not equal, right? I can clearly see 2 is an obtuse angle, and 5 is an acute angle. They are not equal, okay? So I can say 5x minus 10 plus 75, that's going to give me 180 degrees. And now I can solve. So negative 10 plus 75, that's going to be 65. So I've got 5x plus 65 equals 180. Subtract 65 from both sides. That would be 115. So 5x equals 115. Of course, we divide by 5 on both sides, and we get x 23. Let's look at this example. This one asked me to find x and y, so I'm going to have to find two different variables for this problem. Looking at this, I see that I have a series of parallel lines. This time I have 3 lines instead of just 2. That's okay. The same rules still apply. And then I've got a transversal cut between them, line D. So I know that this angle is 60, and this angle is 3x plus 15. I'm not going to worry about the y yet. I'm just going to focus on one letter at a time. So I'll start with x. So I'm just going to ignore this for right now. So what is the relationship between this angle and this angle? And hopefully you're thinking, well, they're on the inside of these two parallel lines, and they're on opposite sides of the transversal. So that's got to be alternate interior angles. And what's the relationship between alternate interior angles? They are congruent. They're equal to each other. So I can say that one of the angles, 3x plus 15, is equal to the other angle, 60. Okay, so I'd want to subtract 15 from both sides. 60 minus 15, that's going to give me 45. So 3x equals 45. And then, of course, we divide by 3, and we get x equals 15. Now, it's important to note, and I wish I had noted this over here as well, but it applies to both problems, that when we're finding x here, I'm not saying that this angle is 15 degrees. That's not what that means. The angle itself, I know is going to be 60 degrees, right? Because these two are congruent. If this one's 60 degrees, so is this one. But what I just want to know is the value of x. So assuming that I've done my work right, I should be able to plug that x in right there and get 60 degrees. So let's just double check that on the calculator. It's good to check yourself every now and again and make sure you're doing the right thing. So we would do 3 times 15, 3 times x plus 15. And I do get 60. So I can feel confident, okay, 15 is right. Because if I didn't get 60, that means I've done my math wrong. So good to always double check yourself. And now I can focus on the y. I found x, now let's find y. So I could go about this 2 different ways. I could either take my knowledge of this angle and apply it to this angle, or take my knowledge of this angle and apply it to this angle. I'm going to go with the 60 just because I think it's easier, less solving involved. It's already a whole number. So if this angle is 60, what's the relationship between this one and this one? Well, now looking at the parallel line A and the parallel line C, these two are also on the interior when we widen our scope. So for the first one, these two are on the interior of A and B, right? But now we're looking at A and C, and these two are on the interior. So they are, just like these two, these are alternate interior angles, which we know are congruent. So I can kind of do the exact same thing again, only this time I'm going to say my y angle, negative 5y minus 10 equals 60. And now we solve. Add 10, so I get negative 5y equals 70. Divide by 5, of course. Negative 5, excuse me. And we get y equals 70 divided by negative 5 is negative 14. Now, this raises an interesting question. Could I have, a lot of students they'll solve a problem like this and then they raise their hand, they'll say to me, well, you can't have a negative angle, okay? And that's true, all right? If we're doing like real life problems like this and you get a negative for an angle value, that's not good. That means you've done something wrong, okay? We don't have a negative measurement of something. But it's okay for a y or an x or a variable you're solving for within the angle, that's okay for that to be negative. We just need to make sure that when we plug it back in, that we don't end up with a negative. So let's just double check, and this will be good too. We'll make sure we get positive 60, but we're also going to make sure it's not a negative 60. We'll make sure this comes out to a positive. So here we go, negative 5 times negative 14 minus 10, and hopefully we get positive 60, and we do. So it's okay for the variable to be negative, just not the angle. So I've given you a picture here. Notice you got 2 parallel lines and you've got a transversal cutting through them. What type of relationship do angle 6 and angle 7 have? So angle 6 is up here, angle 7's down here. So what would we call that type of relationship? And then answer this question. If the measure of angle 6 was 75 degrees, what is the measure of angle 7? Okay, so I will leave the answer in the description of this video. This has been Miss Math Tutorials.